Shoko Suzuki. Today, I will discuss dynamic knowledge as the central theme, exploring the redefinition of humans and the potential for a new paradigm from a philosophical perspectives. This is the history of my research journey. After receiving a scholarship for young scientists from the Heinrich Hertz Foundation, I went to Germany. At the Faculty of Philosophy at the University of Cologne, I studied and worked 7 years on philosophical psychology and psychophysics history from the late 18th to the 19th century, focusing on attempts to understand the mind and the spirit using mathematical and mechanical methods and the philosophy of learning. From the perspective of the relationship between the external phenomenal world and the inner world of the observer or researcher, I have focused on the role of tact, a tactical intelligence or sense of touch, in harmonizing dynamic knowledge and its dynamic manifestations through experimental learning. This research led me to hold a joint position at the Seminar of Philosophy of Education at Kyoto University and the Artificial Intelligence Research Center at RIKEN. At RIKEN, I worked on themes such as the differences between human and machine learning and the redefinition of humanity. So now, let us explore the main topic. Why is dynamic knowledge necessary? First, much of the knowledge we rely on today is static, treated as fixed and unchanging. However, this static knowledge faces several challenges in our rapidly changing modern society. Static knowledge struggles to adapt to evolving circumstances, such as new technologies or global crises like pandemics and climate change. In this context, dynamic knowledge becomes increasingly important. Dynamic knowledge bridges the gap between static principles and the complexities of reality. It provides a foundation for adapting to ever-changing environments and context and effectively addressing emerging challenges. The data and systems surrounding us evolve astonishingly, leveraging algorithms to solve complex problems. However, algorithmic thinking can be seen as a Ouroboros loop within the deterministic matrix that predicts the future based on past data. The Ouroboros, a snake consuming itself in a curricular patterns, symbolizes self-perpetuating cycles confined within established frameworks. In this closed loop, responding reflexivity to new possibilities or future uncertainties becomes challenging. To overcome this closed matrix, I believe introducing dynamic knowledge is crucial. Rather than seeking fixed conclusions, dynamic knowledge embraces change as a driving force for growth. It represents knowledge of processes characterized by evolution through cycles and deepening through spiral motion. while appearing to repeat the same pattern, a spiral advances to a new dimension with each turn. This evolution through cycles and deepening through spiral motion does not return to the same zero, but to a more evolved version of zero. This is a typical traditional Japanese mastery system. I propose that this transformation is the key to transcending the limitations of algorithmic thinking. It sheds new light on the challenge of uncertainty in physics and philosophy, offering pathways to a more adaptive and innovative future. Among the intellectual linkage of dynamic knowledge today, I will share Johann Friedrich Herbart's concept of oscillation and tact as a form of attunement intelligence to optimize it. Herbart's thought influenced diverse fields, including Fechner's psychophysics, Hermann Cohen's philosophy of becoming, and the precise sciences in Vienna, represented by Wittgenstein, Carnap, and Freud. He was often referred to as a second Leibniz. Herbart's impact on Eastern Europe is also noteworthy. His dynamic ontology influenced Kazimierz Twardowski, a discipline of Franz Brentano and the founder of Polish phenomenology and analytic philosophy, and Roman Ingarden, particularly in their dynamic understanding of phenomena and meaning. For Herbart, the essence of phenomena lies in dynamism, with oscillation forming the basis of how existence is perceived. He highlights tact as an intelligence that balances and adapts dynamically to shifting conditions, seeking harmony through interaction with the world. Inspired by Immanuel Kant, who linked to a tightrope walker, maintaining balance while advancing step by step. Herbart saw tact as a skill developed through disciplined bodily learning. Herbart's approach opens new possibilities for development when connected to AI. In this context, the SRISE concept integrating Leibniz topological combinatorics with psychophysics through oscillation and tact suggests a framework where structured mathematical logic meets dynamic, embodied cognition, offering fresh insights into machine learning and human AI interaction. So we come back to the spiral construction of learning with dynamic knowledge. Combining dynamic knowledge with spiral deepening structures offers an innovative perspective for understanding the non-linear processes of knowledge formation and learning. This approach could serve as a key to unraveling the structures of human and AI learning, evolution, and knowledge, which cannot be fully grasped through simple causality or linear development. With the rapid advancement of generative AI, the collaboration between humans and AI is increasingly influencing the human cerebral cortex. Specifically, functions such as reading, writing, memory, word choice, syntax, and the construction of ideas are being delegated to AI. Additionally, by rediscovering specific rules or logic underlying emotional communication, previously thought to exist solely at the level of motion, AI is becoming capable of significantly substituting human functions, particularly cognition, emotion. In the context of large language models, AI functionally mimics human behavior on the surface. However, debates persist over whether a specific emotion exists behind these behaviors and whether AI possesses consciousness or self-feedback, such as feelings of affection or trust. Indeed, in the context of emotional labor, service industry, employees adaptively handle customer complaints by employing techniques that manipulate emotions as tokens, even if they do not genuinely feel those emotions. This can be described as emotional labor, functionally deploying emotions even in their absence. Similarly, humans also engage in emotional labor in workplaces or the families or the schools, and to avoid conflict in superficial interactions. Humans have historically outsourced their functions to these tools through the invention of tools. This process of delegating human functions to tools is a core aspect of humanity's evolutionary trajectory, which has come to be known as technological civilization. In other words, machines have been developed to imitate human functions and improve their precision. Concurrently, humans have become mechanized, while machines have become increasingly humanized. This phenomenon is now materializing as a collaboration relationship between AI and humans. Some AI developers posit that artificial consciousness and artificial emotions represent a new category distinct from humanity. These ideas are likely to spur further discussions, not only in research and development, but also among users. This situation where humans mechanize and machines humanize represents the co-evolution and symbiosis of humans and AI. Will humanity enter a new evolutionary phase as transhumans or posthumans? Will human 2.0 become entirely distinct from who we are today? And yet, what conditions must be met for humanity to remain human? So, How do AI and human learning differ? Emotional AI, regardless of whether it truly feels emotions, is programmed to behave as if it does. In contrast, humans act based on a belief in the existence of emotions and affection within themselves and others. This difference can be understood as one between emotional functionalism and emotional essentialism. However, it becomes challenging to apply the same framework to compare AI and human at the level of language learning. Generated AI can produce contextually and situationally appropriate language without understanding the meaning of emotions. Therefore, we must examine the criteria for comparing AI to humans in this context. If we consider the differences between AI and humans from the perspective of the symbol grounding problem, the key distinction lies in the embodied nature of human experience. Humans, with their physical bodies, connect words intimately with actual memories and experiences mediated through senses and emotions. In this sense, humans' concrete understanding of words remains uniquely achievable. On the other hand, it is said that abstract terms such as democracy can be understood and defined through language by AI at a level of comparable to human. When viewed this way, clarifying the difference between AI and humans prompts us to question whether the function traditionally thought to be uniquely human believed to be exclusive to human learning. Indeed, by investigating human brain functions to understand the mechanism of human learning, we can pursue the possibilities of programming AI. At the same time, by analyzing the mechanisms of AI's machine learning and algorithmic thinking, we can approach a deeper understanding of similar human cognitive functions from new perspectives. We have traditionally described human dynamics, the potential to act, by pointing to evidence of actions such as running or writing, and inferring that the capability to perform these actions exists inherently within us. However, our senses and capabilities are mere classifications and labels humans have imposed on themselves. A more comprehensive view of human dynamics is crucial, including hidden intelligence, such as embodied knowledge and intuition, which differ from reason or cognition. Therefore, by analyzing machine learning through approaches rooted in the intellectual traditions of Herbert, such as psychophysics and phenomenology, or exploring human capability, including tactical intelligence, not as mere quantitative expansion, but as qualitative transformation. We can size this era of AI as an opportunity to embrace a paradigm shift in how we understand learning and human capability. Yeah, then we can say machine learning to analyze and at the same time human mastery with another perspective compared to AI to analyze. These two directions of machine learning system to analyze and the human mastery system to analyze and cross over these two directions of analysis, we can develop the new paradigm of learning and differences and similarities of AI and human brain. It's a begin of the begin. So this is a short essay published a year ago in Springer Nature. The essay begins with the question, did you say thank you to ChatGPT today? Humans tend to inscribe the world around them as a stage for their life history, a temporal and spatial backdrop for the work of living. Not only loved ones and pets, but also personal items like a favorite pen or glasses enrich our lives. Cultures have nurtured the wisdom of expressing gratitude to such objects or performing rituals before discarding them. This way of relating to objects is different from anthropomorphizing, humanize, or treating them like humans in a dependent relationship, as in the case of so-called techno-animism or addiction. Instead, it can be seen as a form of wisdom in managing our relationship with technology. After this article was published, many readers in the West commented that it reflected Japanese techno-animism. However, researchers from Africa and India also reached out, sharing that similar wisdom exists in their cultures and expressing a desire to rediscover and explore these practices. This is a tradition of rituals or the celebrating, and this is so the desire to the future and how the foreigners after the death of the relatives or the children and so on. In the infosphere, a monistic world of information, humans, plants, animals, and even inanimate objects are treated as entities with information, standing on equal footing. In such a sphere, where the boundaries between living and not living, non-living blur, it seems increasingly important to revisit this human wisdom and reflect on its relevance in contemporary contexts. When considering the relationship between mind and matter, it is essential to explore ways of relating to and understanding entities as forms of existence within the infosphere. The cultural wisdom embodied in the technique of anthropomorphism can also serve as a guide for developing new perspectives and methodologies for interdisciplinary approaches. These approaches aim to holistically grasp the interplay between mind and matter and between consciousness and the body. That concludes my presentation today and introduction to Begin the Begin. Thank you for your attention.